Okay, lesson 1.7. Last lesson in this chapter, and it is modeling with functions. So looking at functions, equations, ones that we know, and adjusting them to meet the qualifications. In the first example we're going to look at, we're talking about area of a circle, which, as I said this morning, in my idealistic world, everyone knows the area of a circle because you've been doing it since upper elementary or middle school, definitely. Now, as I said, that's my idealistic world because unfortunately not all of you know area of a circle, but so we're going to talk about that. But example 1 says, write the area A of a circle as a function of its, and there's 3 different things we're going to do here. So the first one's the easiest one. Write the area as a function of its radius. So write the area of a circle using radius, so using r. Okay, then we're going to change it up, and we're going to write area of a circle, but instead of using r, we're going to use the diameter. Sorry, Haley, I didn't move you back. Just dawned on me. Okay, and then the last one, we're going to write area of a circle, but we're going to use circumference as its defining feature. So, let's start with example A. Area of a circle. As I said, you guys are pre-cal, you're juniors, seniors, kind of honor level type math here. In my brain, we all know this formula. And, you know, this morning we decided I was kind of being idealistic and, you know, in my perfect Mrs. Sargent's world. What is area of a circle? I know some of you know it. Okay, area of a circle, the formula I would expect you to know, pi r squared. Now, part A asked us to write area of a circle as a function of its radius. Did we just do that?
Yes.
Yeah, that's area of a circle using r. So on part A, we're done. Because the given formula that you know and use all the time is just that. Now B ask us to change it up, though, and write it using diameter. So, this is where we have to connect. This formula here uses radius. So we need to, what's the connection? Okay, so radius is half the diameter, and you're on another topic, so hold that thought. And you could, radius is half the diameter, or to get started, you could say that 2 times the radius is the diameter, right? But regardless, radius is half the diameter if you have to take that and solve for r. Okay, I don't know which way your brain went first, if radius is half the diameter, or 2 times the radius is the diameter. But I want it to be r equals, because now what can I do? Our formula was a equals pi r squared. What can I use for r? Half of diameter, or d over 2. Now, clean that up a little bit. What happens when you do d over 2 squared, quantity squared? No. How do we square the fraction d over 2? And there's a couple of different ways we could write this. We could put it as all one fraction. If we put it as all one fraction, that's pi d over 4. How I was going to write is I was going to put my coefficients out front. Anyone going to call me on my mistake here? It's supposed to be d squared.
Yeah, I was kind of curious what that was like. I thought we were going to do
Nope.
square.
Just a Mrs. Sargent overlook. So if I pull out my coefficients out front, what I was trying to go with here is pi over 4 times d squared is where I was leading. Okay. Again, it's not wrong if you write pi d squared over 4. It's not wrong if you leave it as pi times d squared over 4. They're all equivalent functions. C. Circumference. Again, in my ideal world, we all know this one. Again, it's my ideal world. I'm allowed to, think what I want to think. Thoughts on circumference of a circle? Pi times d is one of the options. And that's where, Sadie, you said that earlier, and I said, hold that thought. That's not area. So, pi, not r squared, 2r. So the other way this is often reads is 2 pi r. Both of those should sound familiar. I mean, I know they're familiar in there somewhere. So, with that in mind, use one of these to rewrite our formula. I personally would use this a equals pi r squared, which means I need to take c equals 2 pi r and solve it for r. How do I solve for r? Divide by 2 pi. What I do to one side, I do to the other side. And so then what is r? R is c over 2 pi. And now we can take that and plug that into pi r squared. So a equals pi times radius squared. What's my radius this time? C over, what is c over 2 pi quantity squared? C squared over 4 pi squared. I know pi is a number. We can still treat it like a variable, though, and say squared, because you have to square everything there. So 2 squared becomes 4, and pi squared, I'm going to write it as pi squared. This pi out front, I'm going to write as pi over 1 for the sake of my cleanup. Because I'm ready to put a final answer together, and I want to clean this up. You can cancel out a pi, correct? Just like a variable. Whoops. You can cancel out a pi. So if we cancel out a pi, what remains? C squared over 4 pi. And that would be area as a function of the circumference. Okay? We're just combining equations there. Because I'm ready to go talk some volume now. We've talked a lot of area. I'm ready to talk volume. A square of side x inches is cut out of each corner of an 8-inch by 15-inch piece of cardboard, and these sides are folded up to form an open-topped box. Write the volume of the box as a function of x. Well, every year I keep thinking, oh, I should cut out an example here. And I never think to do it ahead of time until I get to this point. And then it's kind of too late. 8-inch by 15-inch piece of cardboard. I can draw a rectangle. Okay. And what do we know about this piece of cardboard? Okay. We've got 8 inches by 15 inches, right? And then what are we doing to this piece of cardboard? Cutting out a square. Cut out a square of this in this corner. I cut out a square in this corner. In this corner. And in this corner. And what do we know about each of those squares? They are side x. And so if a square has one side x, that means all the sides are x. Not that you have to go through and label all of these, but whoops. Just trying to, Now, my original rectangle had sides 15 inches long and 8 inches long. And then we're going to cut out the corners, yes? So these corners of x by x are going to be gone. And so over here, what's that leave? That leaves this little flap right there. And that flap is going to fold up. And on the other side, my flaps fold up. So my rectangle is no longer 15 long and 8 inches wide. Thoughts on how long it is now? And how wide, either or. We have to talk about both of them.
15 inches minus 2x.
15 inches minus 2x. And I guess you guys do realize, I'm trying to figure out that distance right there. If the whole length was 15, and what are we cutting away? An x here, an x here. So if you have 15, you take away an x, you take away another x, that's 15, take away 15 minus 2x. Does that make sense how we express that? We don't know what x is, so we don't know how much is cut out, but it's x. What does that mean about my width that was 8 inches? It's now 8. Take away those two corners. So 8 minus 2x. Okay, that's my visual for you. Now, what was the whole point of this problem? Volume as a function. So, in order to start this problem, we have to recall a little bit about volume. So, we're going to take this piece of cardboard, we're going to fold up the sides. We now have a open top box. How do you find volume of a box? Length times width times height? So rectangular box, you learned this back in middle school, if not before. Thoughts on what those dimensions are going to be expressed as? What's the length of this box going to be? 15 minus 2x. So, my length is 15 minus 2x. What about my width? 8 minus 2x. So my length, 15 minus 2x after I fold those sides up. Width, 8 minus 2x. Thoughts on how tall this box is? He says x.
I believe that's right.
And then he follows up with, I don't know if it's right. Really?
I'm confident.
Think about it. How are you getting the height of the box? It's when you take those flaps and fold them up. How wide are those flaps? X. And so, yes, the height is x.
Look at that guy.
I think he's impressed with himself here.
Those other numbers so happy.
Okay. Now, I boxed that. We're stopping there. Technically, if you needed to multiply it out, we could. You would have to FOIL the 2's and then distribute in the x. Okay. I'm wanting to move on and get through as much as I can here, which is why we're not taking time to multiply that out. So let's move down to example 3, where Mark receives an 8.5% salary increase. His salary after the raise is $36,890. What was his salary before the raise? Okay. Think about this. His salary So in my view, and there's a couple of different ways we could do this, so I'm just trying to get us going somewhere. In my view, $36,890 is kind of the total. because that's after the raise, yes? What are the pieces that go into that? Okay, so he's got, what's X represent? Okay, so we have to have an initial salary here, yes? Do we know his initial salary? No. So his salary before the raise is what we're going to call X. So you have the initial salary, then you also have to add on the raise. Do we know the raise?
8.5.
Okay, his raise is 8.5%. Percent of what?
Salary.
His original salary. What's his original salary? X. So I'm going to clean this up here in a moment, but the idea I'm going to go with is his original salary is X plus, how do you express 8.5% of X? What do you do with 8? So 0.085X, meaning original salary plus 8.5% of his original salary is his raise, and together that's all going to equal 36,890. Yeah, so what is this X is like saying 1X plus 0.085. So 1.085X equals 36,890. Now, could you have jumped straight to that? Yes, some of you may have seen that. That 1.085X is 108.5%. How do we solve this? Yeah, so if you want to do this equation right there, I'm good. Divide by 1.085. Did anyone do it and get it? $34,000. I was thinking it came out nice, neat, whole number. And you can check that, right? You can do 34,000 multiplied by 8.5%. Add that to 36,890. Now the key is there. If we're adding 8.5% on, we did 1.085. Carry that thought process over. What is the cost of an item after a 45% decrease? So now we're subtracting. Okay, again, we don't know the cost of the item, but this time we're subtracting. So the idea of doing X minus 0.45X, because you're doing the cost of the original 4 or 5 times X. What's that clean up to be? What's 1 minus 0.45? Or what's 100 minus 45? 55. So 0.55X, or in other words, if something is 45% off, you're paying how much of the price? You're paying the remaining 55%. So if you're in the store and something is advertised as 30% off, you just need to find 70% of that cost. So just the thought process of the fact this is of the original cost is what I'm writing in there. Like that's what it equivalates to. Okay. A couple more quick ones. Well, kind of quickish. On the back. Okay, example 4. A square is inscribed in a circle. Write the area of the square as a function of the radius of the circle r. So, I don't know about you guys, but first thing I need is a picture. What's it mean a square is inscribed in a circle? A square inside of a circle, where officially, what's happening with the square? The 4 corners of the square are on the circle. I don't know. It's not perfect by any means. Now, so what are we looking for? Area of the square as a function of radius. If you would, let's start with its area of the square, right? What do you know about area of a square? Length times width, except what's special in a square? The length and width are the same. So what is typical in a square is to use S as the side length. So instead of saying length times width, I'm going to say S squared, because it's S times S, which is S squared. That is the typical way to express area of a square.
And that just means it's side squared.
Side squared, right. Now, that's area expressed as a function as the side of the square. We need it expressed in terms of radius. What's radius? Half of the diameter, the distance from the center of the circle to the edge. Now, where is it most beneficial to draw this radius? Notice I'm going to draw to the corner of the square. Okay, and there's a couple of different ways we can do this. I could do it there, and then what if I draw another radius? Okay, that's another radius, right? What shape did I just form? Triangle. What do you know about this triangle? It's a right triangle. It also, someone this morning said it's an isosceles triangle. Okay, so, side note, Pythagorean theorem. A squared plus B squared equals C squared. What's my A and B? So R squared plus R squared equals, what's C? S squared. Okay, what's R squared plus R squared? 2R squared. Now, we have to solve this for either R or S. What are we trying to replace here? We're trying to replace S with R. So we need this equation to say S equals. How do we solve for S officially? Square root of it. And there's a shortcut on this problem, but I also want you to see the general idea. If we solve for this, so S is the square root of 2R squared. Can you take the square root of 2? No, but can you technically take the square root of R squared? Yeah, so we could write this as R square root of 2. Again, some of you will see a shortcut that could have happened. What do we do with this S value? Plug it in. So, instead of area being S squared, area is going to be R square root of 2 squared. What happens when you square that back? We're right back at 2R squared. So if you happen to catch it, when it said S squared equals 2R squared, we could have just stopped there because we didn't really technically have to have S, we just needed S squared. But that's not always going to be the case, right? Sometimes you're going to have to solve all the way. Did we get the gist of that problem? I know I went a little faster because I'm running out of time, but did we get the gist of it? Huh? Okay. This last one is a quick one, if you let me do it. And you'll understand it. Okay? A number added to 4 times a number is 450. What are the two numbers? In algebra, what is a number? She says X. Added to. Plus. 4 times a equals 450. Solve for X. Are you okay with how I wrote that equation, guys? A number added to 4 times that number is 450. So x plus 4x equals 450. What's x plus 4x? 5x equals 450. Divide by 5, and x is 90. I was wondering if I misheard you if you just said the wrong number.
No, I did 30, that's not 35.
And it said, what are the 2 numbers? So one number is 90. How can I find the other number? 4 times 90? Or 450 minus 90 if you want. I like the idea of 4 times 90, which is 360. Okay, your homework, if you haven't already written it down. Page 148. Numbers 1 through 16, 18, 19, 21 through 23. Have that ready to go for tomorrow. Okay? Huh? We can't start a new section tomorrow. That was the last section in this chapter. Just a second, Haley.
So then, I'm fine.